Hi, welcome to another video. Hope you had a good Easter. So what I'm going to demonstrate today is getting Bluetooth, those modules you saw the other week, I demonstrated the other week, a Bluetooth module working with your Pic Microcontroller, but more importantly this video is going to show you how to connect an Android to your Pic Microcontroller and control a few functions. So what I'll do, if you're familiar with the PIC32 and you're using the internal RTCC, if you haven't got a battery backup, when you turn the thing off, the time and date obviously resets to when you first or last programmed it. So what I've got here, just for information, this is the string coming off the NRF transceiver you might have seen in one of my other videos. See, the solar panel's nearly dropped off to nothing. So that's recording my data. Let the screen refresh. Right, so that's the time, and what happens? I've got an 18F 46K22 upstairs clock, GLCD clock, picking up the time 2 o'clock every morning from the MSF receiver, MSF transmitter. What I incorporated the other week was I've got one of the spare UART ports on the 18F chip to send the time via UART. So this up here, look, 1733, or this is actually the time string down there. See, if I turn the light off you might be able to see it. It's black. So it's time, well, that's the string begins with time 1733. One is for Monday, 21st of April 2014, and I'm not sure where the K comes from. So let that refresh again. I think it comes on at 5 seconds past. So there we go, that's the time, and that's the solar panel string again. So what I've done, picked up the various strings here, and I'll show the time up there. So that's, I don't know, for example, digit 6 or I think it's 8, 9, 15, 16. The UART on the pick upstairs seems to put spaces, so I've had to work it out and obviously decode it down here. So 1734, Monday, 21st, April 14. So what I'll do, I'll reset this pick, and you'll see the last time I actually set the time on this PIC. This is a 32-bit microcontroller. While that's waiting to start up, PIC 32 microcontroller on Microelectronica's EasyPic version 7. As you can see there's the Bluetooth receiver, and you can see the red light's on, so it's synced with the transmitter upstairs, and that's the NRF transceiver. That's the receiver. I soldered to a small surface mount Pic microcontroller, so that is just running that. A lot of program just to run that. The advantage with this Bluetooth, there's no program, no additional microcontroller required. You just UART in, UART out. So you see, the last time I programmed this clock, 6th of April 14, and you see the time has just come in at the top, 1735. So what happens, that will on the next minute update the clock. Give it a second, it will update the clock, and then we'll have the right time. There we go, 1736. I forgot what the time was, 12, something like 12:30 or something like that. So the Bluetooth is actually bloody reliable. Never missed a beat in a couple of weeks it's been running. The NRF, I think I'm getting radio interference or some sort of spike from somewhere. So that's the picking up the time via Bluetooth. So if I just run you over to the screen. Right, so all I'm doing with the PIC 18F 46K22, which is the clock, I'm just converting all the time components. See the hours day, week, year, converting them to a string, like into string, and then simply writing UART write text, or UART write 1. So I'm using the UART 1 channel. Hopefully you can see that. So that's all the clock is doing upstairs. It's a regular GLCD clock, and I just incorporated this code. So that's being transmitted via the Bluetooth upstairs, and that's synchronized to this Bluetooth down here, just over there, and picking it up off the second UART channel on this Pic 32. So that's updating that time on that screen every minute. I haven't actually set it to not update it. I was going to update it once a day, but haven't got round to it. And every minute of the day it's spot on. You can see it updates the time reliably. Got the light in the way there. So 17:38 you can see, and there's the time just come in. So because it's still 17:38, it's not going to update it because that was what the time is. As I say, this transmits 5 seconds past the minute, and this clock is running about 10 or 15 seconds fast, so that these interrupts don't actually interfere with the time. So because the time's still the same, it's not gonna, you're not going to see it change. However, if the seconds drift, it would change, but you just wouldn't see it because I'm not showing the seconds. This number here flashing there is actually the EEPROM counter for my solar panel charge current data recorder. Right, so that's the regular Bluetooth. You might have seen the other video. What I've done, I've purchased another pair. So from DevKits, and again got it very prompt shipping, got a pair of Bluetooth transceivers, just over a week of purchasing them, and they'll tell you, have a read if you haven't got any already. The white dot signifies it's a transmitter master, and the one without the white dot is the slave. So what I've done here, connected the slave back up to my TTL stroke UART to USB converter. They're just £1 or so off eBay. Connect to the transmit to the receive as usual. Transmit to receive and receive to transmit. Hopefully you can see that there. Not quite focused in. Should be able to work out the colours there now. And you see VCC, so I've got this this UART device set to 3.3 volts. These are 3.3. If you haven't seen the other video, if you connect to 5 volts, they recommend you put a 1K resistor on the 2 data lines so you don't blow it up. So that's what I've got, a slave connected to the TTL to UART USB adapter. So what I'm going to do, plug this into the PC. Right, so that's connected. Now this is Micro C Pro for Pic. So I'll get rid of that. I was just showing you the program for the clock, the simple UART. So that's all I'm doing, sending the time via UART. So I can exit this, get rid of my calculator. Right, so you saw the time on the Pic 32. What I'm doing, getting the time. Actually, let's scroll down to the strings. So the first one you will have seen is the NRF, and there are various channels you can get on the NRF transceivers, and I'm picking up various strings there. So that's the pipe, which is the beginning of the pipe string for the NRF. You might be familiar with that now. So I'm going to scroll down, you don't need any of that. And this is the second interrupt. Right, this section of the program is picking up the various like hours, minutes, day, date, year in the string location. So you see it starts at 8 and 9, 14, 15, 21, 26, 27. That's picking up my strings, my individual bits. So you might be able to pause that if you want to. This bit down here, because of the clock upstairs, if it sees like a null character or 0, it transmits on this particular software. Upstairs it's transmitting 240 with ASCII 240. So if you go to your ASCII chart up the top, tools, ASCII chart, I'm getting a 240, bit of an odd character, which is that funny looking A down the bottom. So when there's like for example, it's April, so we haven't got any tens of months, so it's 4 and not like 11 or 12 or 10. I was getting a 240 when there should be a 0. So this part of the program, it's looking, if we get a 240, it's calling it a 0. So you might remember from the TFT display earlier, we had 04 for April and not some gobbledygook. So that's what that part of the program's doing. So if it sees a 240, it's a 0, and I've called it MSF because the clock upstairs is synchronized with the MSF receiver. And so down the bottom, this is just simply calling the hours, is that string plus that string, minutes, years, month, day, etc. And then byte to string. So yeah, converting these hours, minutes, day, month, etc. into strings, and then simply printing them in different places on the TFT display. So that's how that bit's working. So now we finish with that. Actually, what I'll do, in case you're not familiar, the way to update the clock. So unsigned long for the RTC time, and this is similar to Microelectronica's example. All you do is temp time for the hours, minutes, seconds, year, month, day and date, which is really, this bit here is the opposite of what you're doing when you're getting the time out of the chip. And you're simply writing the time and writing the date with those figures. What I do at the beginning, I disabled the interrupts, and I'm re-enabling the interrupts at the bottom. So now we finish with that, I can close all. Right, so as with all my other software, or using the UART, go to tools at the top, down to UART terminal. Right, because I'm connected, right, there we go, COM3. So if I connect this, so I'm connected to COM3. So I've got this slave connected to the UART to the PC, and it's picking it up on COM3. Right, so what I'll do, I'll just get this tablet. This is actually from Element 14. It's actually a load of rubbish, but there you go. When I'm putting the addresses in for, I don't know, like Google Play, getting these apps, it doesn't let me put the @ symbol in. So it's absolute rubbish. Right, so if I go back to the Android, let's see if we can get a good picture on this Android. That's my partner's granddaughter. Right, so I went to Google Play and found this BT terminal. So if I connect that, it's a BT terminal for Bluetooth terminal, nothing to do with British Telecom. And at the top, see if I can get you a better picture. Get my roll of solder. So you see this slave isn't connected to anything at the moment, it's just flashing away. So at the top here it says connect a device, and well, this is actually, I've been experimenting, this is the clock Bluetooth receiver that's synchronized with the one upstairs. I didn't rename it, so that's it, just coming at 8C06. This is the slave here that I've connected today and just called it JB 11. So if we click that, connect, and then down the bottom, so if I go, for example, see if we can get you zoomed in or focused in properly. So I'll go, I've already got it there, look. Hello YouTube, send. It popped up there. So that's the Bluetooth slave communicating with the Android and communicating with the PC. So I've just sent to YouTube there on this Android connected to this Bluetooth. Actually the light's still flashing but it's still connected, and it popped up there. So if I just show you again, oh, it's disconnected because I hit the button. So connect. So I've renamed the Bluetooth JB11. So hit the bottom. Now view what's there when I hit the send. There we go. Hopefully you saw that pop up. And send it again. Hopefully you can see that popping up in that other window. Give it one more go. Or let's type something else. So how are you? Question mark. Send. There we go. So hopefully you can see that data there. Can't get you in any closer today to the monitor, but you see that's the strings coming from this Android. So I thought, excellent, that's the Bluetooth on this Android connected to Bluetooth slave. We're sending the data via this BT terminal. So term for BT, so terminal for Bluetooth. Up the top there. Now what we want right, there we go. Hopefully you saw that red writing pop up. So that is using the transmit, using on Microelectronica's UART terminal. Look, hello back to you, send that. Right, so let's type something else. How are you? Question mark. So about to send this how are you down the bottom there. So you watch for it in this window here. There we go. How are you? And then we can type something back. So watching in this top window on the Android. Right, we're going to type this on the keyboard on a PC. There you go. Are you having a good Easter? So I haven't formatted the fonts, the text correctly with the line feed and carriage return, etc. But that's one independent Android communicating with a PC wirelessly using that Bluetooth. So next, I thought, right, I don't want to communicate with a PC, you just use email, something like that. I want to talk to my Pic Micro. So what I'm going to do is, I won't use this other transmitter just yet. I'm going to turn off the clock upstairs. This receiver will become unsynchronized, and then I'll be able to talk or give this clock the time from the Android. So I'll go and turn off the clock now, and come back. I thought I'd do this quick sample before I totally finish. What I've done, I've changed my clock routine, and so now I've set it so the 7th character is going to look for 1s or 3s. So if I go time, remembering my string already set up is looking for a time, so I thought I'll leave it there. So if I go time 333, because I think looking at string number 7, so send that, and you'll see. So I've sent a string of 3s, and we're flashing port A. So then time again sends 1s, and you'll see we got port D flashing. Just see it there. Got a little loop. So let's do that again. So time. So simple Android. So there's the 1s. Port D. I've got it just running in a loop, counted to 50, then finishing, and so that was 1s. Now back to 3s. Send some 3s. So simple routine in a string. You know, whether it looks for 1s or 0s, or you can have it looking for any character you want, so long as you know whereabouts it is in the string. You turn different things on and off. So thought I'd give you a quick demonstration of that. So versatile Bluetooth versus Android, and the term for BT, so terminal for Bluetooth. Fantastic. Hopefully this has helped and explained some of it. Let me show you the loop before I come out. Right, so these are the 2 loops I put in there. If on off equals 1, just going to count to 50 and flash port D, and if on and off, hopefully you got it in the screen there, if on and off equals 3, it's going to flash port A. But more importantly, so the string coming in, just in case you misunderstood the first bit, because I've already got the time set up for my incoming time, I've left it at time, but this time I called it on off is equal to string to 6. That string 2 is because I'm using string 1 for the NRF, in case you missed it. So that simple bit there, on off, it was string 6. And then down the bottom, the if function is going to look for a 1 or a 3 and flash port A or port D. So you know, you can turn it on, turn different things on and off, turn relays on and off, motor controllers, stepper motors, all with an Android. Simple when you know how, isn't it? So thank you very much for watching.